Warm greetings to all. Myself, PRADEEP, Assistant Professor from Department of Civil Engineering, and I'm proud to here to represent the department which is Father of Engineering, called as Civil Engineering. Today, we are going to deal with a topic called simple stresses and strain. Simple stresses and strain are represented from the chapter Strength of Material. Strength of material is a base of civil engineering, and it is a base subject which covers the entire core of civil engineering. So we have to be strong on the core paper strength of material. So today in this video, we are going to see simple stresses and strains. The overview of my presentation, first we will be dealing with stress strain concept. Next we will be moving to Hooke's law, then elastic constants, followed by stress strain behavior of materials and tension test on mild steel and HYST bars. These are all the concepts. With these concepts, I'm going to do a test on tensile test using a universal testing machine. First, what is meant by the term stress? Stress is defined as the internal force resisting per unit cross-sectional area. That is, if a particular person, for example, if you consider me, I am a human, I have some ability to do the work. Per day, I can do more than, if I want to carry a liter of waters, I can carry more than 10 liters of water with my weight. If I'm dumped with 20 more liters, I can't able to lift it. My body will slightly move this side. So there will be a change in position. So because of the internal resisting force, that load is applied on me, my area is getting deteriorated. So this is known as stress. So stress is denoted by the symbol sigma is equal to P by A, whereas P is the unit load and A is the area. The unit of load is Newton and the area is mm square. So this is a basic concept called strain. Next, I'm moving to types of stresses. There are three different types of stresses. First one is the tensile stress. Second one is the compressive stress. And third one is the shear stress. Now I will do it with a live example. Now I am standing at the straight. One of my person is pulling me from the left side, and another one person is pulling me from the right side. Both of the persons are pulling me. So I will get deteriorated, and the forces from the left and right are called as tensile force. Whereas the compressive force, in simple term, it is called as pushing force. For example, if I am standing on the straight, one person from the left side is pulling towards me right, and from the right, the person is pulling towards the left. So in that situation also, my shapes get deteriorated. So this is called compressive. Whereas the shear force, it will get slide across the area. Either it won't be tensile or it won't be compressive. It will be in the sliding. So this was explained in the diagram here. So my next one is strain. What is meant by strain? Because of all these things, that the load is happening, stress is going. So because of all these happenings, there will be a changes in the dimension. That is length, breadth, depth, width, and diameter. These are all we will call it as dimension. Basically, strain is a deformation produced per unit original dimension due to the applied stress. Because of the stress, there will be a changes in the dimension. There are many types of strain. What are all the different types of strain? Longitudinal strain, lateral strain, shear strain, volumetric strain. What is meant by linear and lateral? If the strain which is changes only in the length, we will call it as linear strain. Whereas the changes which is happening in breadth, depth, diameter, we will call it as lateral strain. So this is a basic difference. Now you will be having a doubt, what is the unit of strain? As I earlier told, the unit of stress is Newton by mm square. Whereas the formula for linear strain is change in length by original length. So change in length, the unit of change in length is mm and the original length is mm. So both the mm will get cancelled and there will be no unit for mm. So it's an important question in examination point of view. You will be having an MCQ question. What is the unit of strain? So you have to answer it as no unit. Next we are moving to the important topic called Hooke's law. Why we have to study Hooke's law? Because the stress and strain are getting connected in this law. So within an elastic limit. Within an elastic limit is a key word, because many of the people will tell stress is directly proportional to strain. Whether is it a correct definition for Hooke's law? Definitely not. We have to say within an elastic limit. So the range matters. So within an elastic limit, stress is directly proportional to strain. To remove the proportionality, I am introducing a constant called E. E is nothing but the Young's modulus of elasticity. So next we are going to see what is this Young's modulus of elasticity. What are all the elastic constants? That was my next slide. This is the elastic constants. Elastic constants are the material that describe how a material deforms under applied load within the elastic limits. Basically, there are four elastic limits. First one is Young's modulus, second one is rigidity modulus, third one is bulk modulus, and fourth one is Poisson's ratio. So these are all the four elastic constants. By doing any two relationship, either if you know E or G, you can find out K and 1 by M. Or in case if you know E, Young's modulus, and 1 by M, we can find out G and K also. So next one is Young's modulus. Now I am going to explain what are all the four elastic constants. First one is Young's modulus. Young's modulus is nothing but the ratio of stress to strain. What is the unit of stress? Newton by mm square. What is the unit of strain? It has no unit. So it can be denoted in the unit Pascal, megapascal, and gigapascal. Now you got to know about the new term called megapascal and gigapascal. What is megapascal? What is gigapascal? If it is into 10 to the power of 3, then we will call it as Pascal, Newton. If it is 10 to the power of 6, we will call it as megapascal. If it is 10 to the power of 9, we will call it as gigapascal. Then what is the application? We are used to find out the tensile and compressive members. Out of four elastic constants, now we have completed one. Second, we are moving to shear modulus. Shear modulus is a ratio of shear stress to shear strain. Your shear stress is denoted by the symbol tau. This symbol is known as tau. This symbol is known as sigma. So these are all where it is used. Where Young's modulus is used in tension and compression, whereas the shear modulus is used in torsion of shafts. What is the example for torsion of shafts? Now we are having a door in our home. While opening our door, that round material will rotate. That is called a torsion. That is an example of torsion. Next, I am moving to bulk modulus. Bulk modulus is something related with water concept, water structured, overhead water tank, because the explanation itself clearly tells it is a ratio of hydrostatic pressure. Hydro, what does the word hydro means? It's a water. So hydrostatic pressure to the volumetric strain. Hydrostatic pressure is noted by the symbol psi, and EV is a volumetric strain. Next one is a Poisson's ratio. This is an important concept that we have to know. What is meant by the term Poisson's ratio? Poisson's ratio is defined as the ratio of lateral strain to the longitudinal strain. Longitudinal strain has another name called linear strain. So if a material, if we find a lateral strain and longitudinal strain, we can find out the volumetric Poisson's ratio. Then what will be the Poisson's ratio unit? Poisson ratio has no unit. And in examination point of view or government examination point of view, you may get a questions on what are all the typical values of Poisson ratio. Behind that, especially you have to know about the value of steel, because steel is a common material we are using in civil engineering. So what is the typical Poisson ratio value of steel? If they ask in the examination, it will be in the range of 0.27 to 0.30. Next one is, as I already told, there will be, if you know any two relationship, we can find out another two relationship. What is that relationship? These are all the relationship. E is equal to 2G into 1 plus mu. This mu can be denoted as Poisson ratio. This is the value of Poisson's ratio. Next one, E is equal to 3K into 1 minus 2 into 1 by M or mu, Poisson's ratio. Then the last relationship is E is equal to 9 kg by 3K plus G. In an examination point of view, you may get a question. The Young's modulus value of a material is 2 into 10 to the power of 5. And the Poisson's ratio is 1 by 3. Calculate the bulk modulus and rigidity modulus. If you get a question like this, using these relationships, you can find out the value. Regarding the GATE exams also, you may get one questions from this. Next one is a stress strain behavior of material. Every material will behave differently based on the stress and strain, because every material has a different characteristics. Whereas the steel behave in a different way, aluminum behave in a different way, whereas the concrete also behave in a different way. So depending upon the stress and strain relationship, the material may vary in strength, stiffness, ductility, and the toughness of a material. This is a stress strain curve. For example, in civil engineering, the stress strain curve for a mild steel was an important concept. Before explaining this slide, I just want to show this one. These are all the limits. OA, proportional limit. Like you are fixing a UTM, in UTM, you are fixing a mild steel. In the next slide, I will explain the UTM test. Before that, you have to know the limits. OA is a proportional limit. AB is the elastic limit. BC is the yield point. CD is the strain hardening point. D ultimate tensile strength point, D and E necking, and E is the fracture point. Now you can see the diagram. O to A. In this point, the steel will start to yield. Then it will be A to B, then permanent deformation, then ultimate tensile strength and fracture. With these concepts, now I'm going to perform a small laboratory test. Tensile test on mild steel bar. For doing this experiment, we need the following apparatus. What are all the apparatus? Universal testing machine, which is a very important machine in Department of Civil Engineering. Universal testing machine, followed by mild steel bar of different diameter, like 30 mm, 40 mm. So you can take your diameter. Vernier caliper. For why we need a vernier caliper? For example, if this is my steel rod, I have to measure this diameter. I will place the vernier caliper and I will see the main scale reading, vernier scale reading, least count bit, then I will calculate all, as you all read it in physics. So this is I'm using for vernier caliper, micrometer, scale and measuring tape. This is the procedure. First, in the universal testing machine, I will fix the rod and I will apply some load. From the top, it will be moving down, and from the down, it will be lifting down. So from both the sides, they will be lifting it. At one point, necking will be formed. What is meant by necking? Necking is nothing but that the point where the steel will get break. So that is called necking. At one particular point, necking will apply, and at a particular load, the steel will break down. This is the tensile test. So this is what I explained in the procedure. So in today's lecture, we have seen what is meant by stress, what is Hooke's law, and what is the stress strain behavior, and a small laboratory experiment. And it's happy to share this content with you. Thank you.